Hey there, we're going to talk about electron configurations today. And so I've got this periodic table up here for us that helps us see where the S and P and D and F blocks actually fit into our periodic table. Though you certainly do not need this labeled periodic table to do electron configurations. This is just a good place to start because it helps us understand how the periodic table is organized. So let's pick an easy one. We'll just start right here. So that would be boron. So we're going to do the electron configuration for boron. Remember, electron configuration tells us what orbitals and shells all the electrons in boron, where they're located. So we're accounting for all the electrons, just like in a man-and-well diagram. And I can draw the man-and-well diagram for boron really quick. We are accounting for the different energy levels. But what we now know is that this third energy level here, or the second energy level, the third, the fourth, etc., everything past the first energy level is broken down into subshells. So it's not just one energy level with these electrons on it, there's some subshells going on there. So that's what the electron configuration is going to show us. It's kind of showing us the same thing as a man-and-well diagram, just in a little more detail. So we are going to follow the periodic table. We're going to kind of read it like a book. So to get to boron down here, I have to go through the 1s. So that means the 1s must be full. So we start with 1s2. That tells us there's 2 electrons in the first energy level. That's an s orbital, big sphere shape. That's the bottom of the well. So this is the same thing as the bottom of the well, 2 electrons in the first energy level. And boron's over here. So to get over there, we have to go through the 2s. And the 2s is full. So we write 2s2. And then you see we're over in the 2p section now. So, but there's only 1 electron in the 2p section. Boron's only 1 in. So as long as we're talking neutral atoms here, that's just 1 electron. So the electron configuration is 1s2, 2s2, and 2p1. Now if we compare that to our man-and-well diagram, you see we're saying the same thing. This is the bottom of the well, and then this is that second energy level. It's just in the man-and-well diagram, we have all 3 of those electrons just clumped together. But in the electron configuration, we see there's still 3 electrons. 2 plus 1 is 3. It's just 2 of them are in the s orbital and 1 of them is in the p orbital. So again, the electron configuration is just showing us a little more detail compared to the man-and-well diagram. So let's come over here and do chlorine. So with chlorine, again, let me do a little eraser here, get this out of the way. It's kind of down the periodic table. So there's going to be a lot of orbitals that are full before we actually get to chlorine. And I can draw you don't have to draw the man-and-well diagrams to do these. I'm just showing them to you so you can make the connection between the two. So if I was drawing the man-and-well diagram, I'm going to run out of room. Okay, so there'd be 8 on this energy level and 7 on the third. So I kind of ran out of room there. The guys are coming out of the well. So imagine the well is more like this. All right. So 2, 8, and then 7. All right, so let's get to chlorine down here. So I have to go through the 1s2. So my 1s2 is full. My 2s2 is full. My 2p6 is full. My 3s2 is full. Then I go 3p, 1, 2, 3, 4, 5. 3p5. 3p6, 1 over, would be argon. So 3p5, that p level's not full. And let's, again, compare this to our man-and-well. That's your first energy level. You got 2 electrons there. This is your second energy level. It's got the 2's in front. You got 8 total. We had 8 there. And this is our third energy level. You got 7 total, and we had 7 there. Again, it's showing the same thing. It's just telling us that we have some suborbitals within those energy levels, so it's in a little more detail. Now I'm going to show you a trick here because sometimes these get really long and we don't want to have to write all of these numbers and letters. So we can do what's called an abbreviated electron configuration using the noble gas shortcut. So I'm going to go to the noble gas before chlorine. So chlorine's right here. I'm going to go one row up and all the way over to row 18, or column 18. So run one row up all the way over to column 18. That's right here. One row up all the way over to column 18. That's the noble gases, and it's neon. So this right here is the electron configuration for neon. 1s2, 2s2, 2p6. That's the electron configuration for neon. Instead of writing out this part, I can just write bracket neon. So I don't have to write 1s2, 2s2, 2p6. I go to neon, and I can start right after neon with 3s2. Right, 3s2, 3p5. And that would be the abbreviated version of that electron configuration. So that's one tool we can use. This is the noble gas shortcut. So you just you go up one row over to the noble gases. That's where you're going to start. And then you just can pick up right after that. So you can pick up in the next row with the 3s2 or 4s2, wherever you're at. And that gives you a little less electron configuration to write, especially when you get into the long ones. So you just want to follow the periodic table across and then go down, across and then down. And if you have a big one, which you don't have those on a quiz, but in class we've done some, you hit a D and an F orbital. So if I go 4s, it then goes down to the 3d and then back up to the 4p. And I go to the 5s, 4d, 5p, 6s, then it's going to drop down to the 4f, 5d, 6p. So you're just following the periodic table across. You'll notice this is an expanded periodic table. This chunk right here, you usually see it down here. But we are showing this in its actual form where it goes. So we usually see it like pulled out, but now we've stuck the puzzle piece back where it goes in the expanded form, and that's actually where you find those lanthanides and actinides in the periodic table, is that chunk there. So that's your basic electron configuration.